Hey guys, it's Jim Bounds at Motorhome Rehab Ranch, and if you're one of our weekly Ranch Hand followers, you know that I'm back from the road trip to Oakton, Virginia. Got a couple of days rest and sleep and good food from Janie, and I'm back. All right, so what I wanted to do right now, everybody, I've had a lot of comments that I can't wait for the video about the download and the takeaway from the road trip. That's fine. But during this, it came up about the Semlax ACR-160. I've had a lot of people ask me about this, and in this road trip, it really figured in. All right, so let's do that. Let's go down this ACR-160 rabbit hole. And what's it about and how to put it in. It might take a couple of episodes, but let's just see. All right, so this, and there'll be pictures at the bottom of the video. This is a Semlax model number ACR-160. What is it? It is a combiner, but it's a unique combiner in that you'll have, like, this side would be the right side of the boost cylinder, this side would be the left side of the boost cylinder. It will connect either direction that is charging. It isolates the systems and will act as the battery boost cylinder at the same time. So it's a very cool machine. Not just have another cool machine and change some stuff. The ACR-160 is the main ingredient or the centerpiece in changing to a one-wire alternator. Okay? To take your alternator and go to a one-wire alternator. You say, well, why am I going to do that? It sounds complicated. Well, mine's not working. I'm going to leave it alone. No, don't mess with it. Gentlemen, if we do nothing more, I want to dispel this completely. Okay? Think about this. Don't you hate when I say that? Think about this. But think about this. Original system, you have a alternator. It has a red wire coming off the back, which, by the way, this nut right here originally was the only metric nut on the entire coach when it was produced. That was a 10 millimeter nut. Mine didn't have one on it. It had a 7/16, but the original was a 10 millimeter. So, red wire coming off of here. Then it has a 2-wire connector plugged into the side of it right here. It's got a large red wire and then a lighter colored, smaller gauge wire. Okay, we're going to talk about this in a minute. All right, now, this Delco alternator, the Lester number's M-7157. Lester number is a universal rebuilder number. So we have a Type 1 7157 alternator. Now, being the Type 1, it was one of Delco's first ideas going from a generator to an alternator. Now, with a generator is not charging, sitting there at idle. But as it goes up and it creates more voltage, the regulator clicks and then it charges. It's a very, very simple system. Well, what Delco did with the alternator, since it would put out voltage at any RPM, they made a regulator that was on-off. And they fooled it by thinking it needs to be on all the time, because this small wire here fed a voltage a little bit under the battery voltage. That turned on the regulator in the alternator. You see? Now, what brought that voltage down just a little bit? The 38-inch long piece of nichrome wire that's wrapped around the harness right behind the radio. When you turn your key on, that light comes on, that nichrome wire is energized, and it is feeding here a voltage just lower than the reference voltage. The reference voltage comes with this other wire. This wire essentially really goes right to the battery. I mean, I don't want to mess up my drawing here, but it would go, this wire would actually electrically go right to there, making sure that the alternator saw the true voltage of the battery and compared it to this one that had 38-inch long wire and then turned on. You dig what I'm saying? All right, now, and it all worked. And it would charge grandma's car, let her idle. It would charge at idle speed. But the problem is you put 2 or 3 batteries on that thing at idle speed, the diode pack in this thing gets too hot and it burns up. All right. With a heavy load, this kind of circuit would not do well. A standard load, that's fine. So GM changed their part in mid-production, which usually never happened. If they had an upgrade to a 7157, they'd make a 7158 or a 7177 or something like that. They would not change, because anytime you need a 7157, by golly, that worked. But they realized that they're really burning up alternators because people are asking them to do too much. You got a dead battery, you jump it off and take the jumpers off. That alternator goes, oh, stop it. Don't do that. GM, in their production, recognized the fact that they want the alternator to charge low current at low RPM, and as the engine and the alternator spools up where it can create more current without not creating more heat, it would allow it to do it. Now, how did they do that? All right. This is something I have not explained before. Think about this. Oh, here we go again. Okay, this wire right here is at a potential a little lower than the red wire next to it. How did they do that? They took a piece of single strand nichrome, in other words, toaster wire. It's 38 inches long. Now, the length of the resistor wire will determine how much drop it is. Why? Because it's a resistor. Okay? Well, this wire is wrapped right here, is right behind the radio, is the whole harness. And this wire resistor is wrapped inside that harness and then got the tape over it. All right? So if you pull the back of your dash off, which I'm going to show you on the next video, and you put your hand down there and look at that big black harness running across the back of underneath the radio, look for any heat damage. Look for where it's gotten hot or anything that's going on back there. I would even take a knife and open it up, won't hurt it at all, right there on behind the radio. Open it up and look at the strands of wires in there for any kind of a heat damage. Okay? There is a small wire, it's a small brown wire, is the one that we're talking about. Now, how did they get this alternator from being on off to ramp it up? This resistor wire, 38 inches long, is 10 ohms. Okay? Now, if you turn that off and you put a 100 ohm ceramic resistor in place of this resistor wire, in other words, turn off the resistor wire and replace it with a 100 ohm, guess what happens? It charges 5 to 7 amps at idle, and as you rev up, your output goes up. So originally we had the alternator light circuit, which essentially changed from 10 ohms to 100 ohms. Make sense? Then we got a little bit smarter. We want a bigger diode pack, and we don't want to have anything having to do with this nichrome wire circuit. Most alternators today are called one-wire alternators. Okay, now what a one-wire alternator is, remember, right here we have a 12-volt reference that goes to the battery. Then right here is this resistor circuit. Unplug that. Internally, this alternator, that's what makes it a one-wire, internally has a circuit that does what the regulator needs, supplies it 100 ohms at the diode pack to turn that thing on internally. So one wire alternator. So you do not need this connector. There's nowhere to plug it in. And if you look at this one, and again there'll be a picture, he's got a rubber plug over where that 2-wire connector plugged in, because the only connection is going to be this red wire right here. And in that you're going to be putting a larger output diode in it, you want to bi-wire that. What I mean by bi-wiring is that one wire coming out is going to handle all of the current output of that alternator. If you could up gauge that wire, it would be a good thing. But where it is, it's kind of real tight in there. And if you tried to put a really big wire in there, it might ground out. So what you do is you get an 8-gauge wire, put it on the same terminal. The original one was here. So you bi-wire and put 2 wires and run them right along together and go right to the center terminal on the isolator. Okay, we'll talk about that in a minute. But you want to bi-wire a 1-wire alternator. Okay? All right. So you take it to your alternator starter rebuilder, and you tell them you have an M7157 type 1. You'd like to have it rebuilt as an M717 type 2 with self-exciting. And most builders go, okay, yeah, all right. So they'll build it for you. You come back and you put it in. Now, you say, well, so I have to have a Semlax and I have to have a 1-wire alternator to make this happen, right? No, that's not right. You can get a 1-wire alternator, which solves a lot of problems with this trigger circuit, solves all this hoopla down here. And you can double gauge this wire, bi-wire this right here, right? And have a lot more output and a lot more reliable alternator. And any alternator shop will know what this is when you go in. Can you go to Walmart Auto Parts or AutoZone? Probably not. Okay, and in a way I say, oh, I made this thing where you only got to go to one. It's so much more reliable. It's so much better. That the last 3 trips I took, the last 2 trips before this last one, we had alternator problems. Okay, so at this trip, I kind of spiked the gun. I went ahead and decided to put in a 1-wire alternator. But I did not want to go through putting in the Semlax first. What I want to do is I wanted to show you guys that I could take a original electrical system with the boost solenoid, there'll be pictures, boost solenoid with the battery isolator, with all the stuff that was in there before, put in a 1-wire alternator, do not plug it in. There's nowhere to plug it in. Then you want to take this right here is a battery isolator. Now what does an isolator do? What a battery isolator does, and you have one, it's that blue fin thing right here. What this battery isolator does, it's a check valve. If it was plumbing, it would be a check valve. It will allow current to flow this way to battery A, which is your engine. It will allow current to flow this way, battery B, which is your living area. Now, don't ask, is it the top one or the bottom one? 50 years of good intentions, who the heck knows? But follow this wire, one of those 2 will go to the vehicle battery positive. It's that right there. And it's the main termination for your living area, for your engine battery. Your starter goes to it, your battery goes to it, your fuse box goes to it. Everything comes off of here, and this goes to here. Now, you say, well, that's a good thing because this battery doesn't see that battery. Well, that's cool. Problem with that thing is this thing pulls 0.8 volts to do its job. Now, the output of your battery is 14.1. Okay, take 0.8 volts against that, away from that. That's 13.7, 13.8 13.4. So if this puts out 14.1, the best that will ever happen to your engine or your living area battery is 13.4. Follow? So this is an energy sucker. Make sense? This is where the Semlax comes in, because here's what a Semlax does. You take out your isolator. You take out your boost solenoid. Okay. There's a really bad drawing of a Semlax hookup. All right. Your alternator, this bi-wired, remember that? That goes to A1. Right there. Okay. Likewise, everything that was on the right-hand side of your boost solenoid, which was the engine electrical system, will also go to A1, which also the vehicle battery positive would go to A1. Then everything could come off of there. You follow? But everything that the engine battery saw goes on to A1 side. Now, everything on the left side of the boost solenoid was your living area battery, right? So your living area battery, everything on the left side of the solenoid goes to A2. Everything here, anything that went to A2 goes, anything that went to the left side of the boost solenoid goes to A2. Make sense? As you do that, you'll be pulling out the wires that went to the isolator. You'll be pulling out a whole bunch of wiring and stuff like that, and it'll clean it up because you no longer need a boost solenoid. You no longer need the isolator. Now, here's how the ACR-160 works. You got 3 terminals. They're male spade terminals, so you can take a female spade. There was an orange wire to your boost solenoid right on the front of it. There's a black wire, which went to ground, an orange wire that hooked up to the right smaller terminal on the boost solenoid. You take that off, and you run it right to here. Right to here. It'll be an orange wire. Okay? Now, the black wire, there was an orange one and a black one. It ran that boost solenoid. The black wire goes to right here. This is your ground right there. Okay. Now, this wire, this terminal, male spade, we don't use. If you want to have an indicator light, if you're a pilot and you want to have a light saying, oh, look, it's flashing, it's working. Okay, hook it up. I'm not caring about that. Don't need no stinking light. So we hook up here. What that does, when you hit the boost switch on your dash, it will mechanically tie together in whatever condition the A1 and A2. Boom, it's tied together. Okay? So this is your override kick. This ground wire, if you want to turn it off for some reason, you take the ground out or put a switch on the dash that would turn off the solenoid, but we don't care about that because we're always going to have it on. It pulls something like 40 milliamps or, yeah, something stupid. So center terminal to ground. All right, it's installed. Now, what it's going to do, say you were plugged in. You had power, you're plugged into your garage. You have AC, and the AC goes to a power converter, which we all know, which charges this battery, right? This is your living area. This is your power converter, okay? So you got 40, 45 amps, whatever. So A2 sees a higher voltage than A1, because A1 is your engine battery, and the engine's not running, it's not being charged. It's just regular battery, 12.5 up to 13.1. But the ACR-160 sees, oh, this side's being charged and this one's not. So it will automatically shunt current to this side, and it will charge the engine electrical system. Now you unplug. You no longer have the power converter on. You're not charging your battery from the outlet. And you go start your engine up. All right. So you'll have a higher voltage on A1. So the Semlax sees that, and it will shunt voltage to your living area battery automatically. So it's just such a good thing. It's a great thing. It doesn't pull that 0.8 volts current to do its job. It pulls truly just about nothing. It's solid state. It is waterproof. Now, how do you get it to work just the alternator? All right. If you jump the center terminal on the isolator, you have 3 terminals. Center terminal is your alternator output. One of them went to the engine battery. One of them went to the living area battery. Engine battery right here. Living area battery right here. So you take this terminal and put it on the center one. You say, why? Because that alternator, one wire alternator, needs to see voltage all the time because that's what it uses for its reference. If you hook it to the isolator blocks voltage. So you will see 0 voltage on the center terminal of the isolator. That one wire alternator needs to see voltage. So you run the output of the isolator, the blue fin thing that goes to the vehicle battery positive. You take it off and you run it to here. Okay. Now, if you blow up on this video here, on this picture, when you download them, you can see the blue fin thing here. But I have the center terminal and the terminal going to the vehicle battery positive on the same terminal right there. You see that? Let's see. There, right there. So here's the blue fin thing. This one went to the living area. This one went to the engine. I took it off of here and put it to the center terminal. What that does is it allows the alternator to see the battery. All right, now, we left Thursday morning at midnight with this electrical system. I had the alternator modified to 1 wire. I installed it. I made this one modification, this one change on the battery isolator, and we drove to Oakton, Virginia. So if you're worried that it's a wiring nightmare to put in a 1 wire alternator, you see what it is. It is not. Okay? Now, when I got to Oakton, I took out the boost solenoid, the isolator, took all that stuff out, and here you see the Semlax ACR-160. Everything on A2 was the original living area stuff. Everything on A1 was on the right-hand side of the solenoid. As you see here, the vehicle battery positive goes right to it, right there. This wire here is the one off the alternator, directly out of the alternator, and it goes directly to the vehicle battery positive. So you can see that this wire is hot all the time, which that alternator needs. Everything on the right side of the solenoid is here, left side of the solenoid here. I had to extend this to right here because that's the orange wire that triggered the boost solenoid. And then right here is the ground. Gentlemen, that's it. That's all it takes. You can see that you can drive just with the 1 wire alternator. So there is no reason why you should not do this 1 wire alternator. There is another video, maybe 2, that I did about this. In conjunction with that, you see that if you do this, you'll have better charge capacity. You'll simplify your wiring a whole bunch. So, eyeball, zoom in on those pictures below. Be much, much cleaner, much more organized. And when you finish doing this, you will understand this circuit completely. You'll understand that the plug-in APC thing that you plug into this connector, we don't even want to use the connector at all. I don't want to use that alternator light trigger circuit at all. Now, your alternator light won't work. You got to make sure that you have a voltmeter. because the voltmeter tells you if it's not charging, it'll be 12.5. If it is charging, it'll be 14.1, 13.8, whatever. Last thing, you folks that have a 75, 6, 7, and 8, back at the living ear, back at the generator, where that battery is, you'll see another boost solenoid back there. And you'll see another orange wire that runs it. Call me if you don't see it, but I know you will. It'll be on the right-hand side of the compartment. The trigger wire that runs that is the orange wire. Cut that wire. Insulate it off. Okay? That will fool the Semlax. So do away with that. In another video, we're going to replace that with a 160 amp circuit breaker. Replace all that stuff back there. We don't need all that stuff. We're going to redo all that, do it on a video, and I'll show you what's happening there. But for now, just cut the wire. Done. All right, guys, I hope this helps. The next video, I'll tell you a little bit about the road trip a little bit. You can see that this was the electrical system that I did there. When we got to Oakton, I got there. We got there real early, early Thursday evening. Spent the night, got a little bit of refreshment. Pulled that thing up, changed all that stuff there in his lot because I didn't want to leave and have him do it, so I did it. And also, I wanted to show you guys about it. So now he has his one-wire alternator properly connected with an ACR-160. Hope you do too. If you have any other questions, first thing you do is to comment. Okay? Hit like if you like this, and share and all that kind of stuff. It will be in our database under electrical. All right? So for you guys that want some in-depth information, here you go. If you guys want to talk about road trip, I'll see you next time. Thanks a lot. Bye-bye.